Hey everyone, welcome back to the shop. I'm Dan. Today we are putting some of the final touches on the 289 build for the 45 International pickup so we can get actually back onto the pickup. Last time, if you remember, we left off, we measured for push rod length for the new push rods because we installed a Summit Racing camshaft. But in that process, galled up and stripped out one of the new rocker arm studs. That was all my fault. I was running those self-locking nuts too fast, and the heat buildup caused the galling. And yeah, I should have known better. But luckily, I was able to pick up a 2-pack of ARP head studs, so I didn't have to buy a whole new kit. Part number 134-7124. It says these are for a Chevy small block, but they work for the 289. So I already got the sealant cleaned out of the old hole. So we'll throw the new stud in, and also got new lock nuts for the rocker arms too. So we don't have to worry about that. And we got new push rods. I don't know if it matters where the push rods come from, but we're using Engine Works. These are chrome moly. 80,000 swall. We're doing worked out to 7 inches long on the exhaust and 6.8 inches long on the intakes. So we'll get this put together and get the lash adjusted, and after that get the preload adjusted. For stock solid lifters, you want between 30 and 60 thousandths preload. So we'll do one turn on the rocker arm nut past full, past zero lash. That'll give us about 40 thousandths with the thread pitch on our rocker arm studs. So get the camera repositioned, and we'll get this going. Make this try to make this a quick video. For the thread sealant, I'm just using Permatex high temperature thread sealant. It holds up to 400 degrees Fahrenheit. If our cylinder head temperatures are higher than that, because of insufficient cooling, we have bigger problems. And this is what I use on all the other rocker arms, because some of these go into the water jacket in the heads. And the torque on this is 55 foot-pounds. So that's 660 inch-pounds. I already got my torque wrench set. Put way too much on there. Just wiping up the excess that extruded out the base. All right. So we don't mix things up. We'll do our inlets first, even though these are labeled. Just set them in there because we need to assembly lube them. Spot of assembly lube on both ends of the ball. suppose for cleanliness could just do the intake side, or do the lifter side first. I'm just feeling for alignment, kind of fingering the exhaust port, exhaust valve, exhaust stud lines up with. So, and then do guide plates, push rod guide plates on this because these early, I don't know if zoomed in on that at all, these early 289 heads have really narrow guides already cast into, light here, really narrow guides cast into the heads. So they have like built-in guide plates essentially. Actually, I could do this. This makes it easier. I apologize for this. I film these videos after I get off of work and on the weekends when my brain is just fried from the week. So and a spot on the tip of the rocker, or tip of the valve. To help prevent going, and hit the threads with some dry film lubricant. Clean up the gasket mating surface before I put the valve cover gaskets on. Do the threads on the studs, and then I'm going to hit the threads on the nuts. And just putting some semi-lube on the fulcrums. In service, all this gets lubricated by oil flow coming up through the lifter, up through the push rod, and through the rocker arm, or in operation. Well, whatever, either one. Service, operation. And when I set the lash, I'll run these nuts slower than when I was measuring for push rod length. And typically, you have to worry about torque when you add lubricant to a fastener that's not supposed to be lubed. Your applied torque ends up being higher for your torque setting because I was just looking at this today at work. A not insignificant portion of your torque just overcomes rotational force. So, especially when dealing with self-locking nuts. I wasn't looking at work for this. Dealing with a similar issue with brake mounting bolts on an aircraft. And these self-locking nuts, replacement nuts, they're stock replacements. They're Mellings. And again, I'm going to borrow a procedure from Vice Grip Garage. I'm going to go through, set everything to zero lash, and then rotate the crank 90 degrees, set it zero lash, and keep doing that for 2 full rotations of the crankshaft. And the idea behind that is 2 rotations of the crankshaft on a 4-stroke engine, the camshaft will make 1 rotation. So you will hit the base circle of all your cam lobes in that 2 rotations of the crankshaft. And if you just go through and set zero lash in that 2 rotations of the crankshaft, you will have hit every single valve or every single push rod for zero lash. So we'll just go slow this time. And zero lash should be no up and down movement. You know, stiff rotation, but no up and down. Yeah, we'll hit 0 lash on that one. Going slow because I'm a little scared of these because I don't want to get into another situation where we're going to damage threads. That's always a problem when you're mixing components. Like the nuts are made by Mellings, the studs are made by ARP. They're supposed to be both 3/8 fine thread. And I see a problem that we may have. I'm bottomed out. This number 1 cylinder is at top dead center, so theory should have 0 lash on these, but I am bottomed out on my nut. I don't have 0 lash. And that's because I'm using stock rockers with aftermarket studs. So I'm going to have to do some digging, see if I can't put a washer between the fulcrum and the nut. Most importantly, see if I can't get these apart. Let them cool off. See if I can get those apart without stripping. So I'm going to call it here before I do any more damage and come back with an answer. All right, we're back. So the solution I came up with is to shim between the fulcrum and the nut. So that's what we're going to do. So we're going to add about 2/10 of an inch worth of shims between the fulcrum and the nut. It's not going to change the geometry of anything because it's going on top of the fulcrum. But it's kind of be expected when you're mixing technologies. Like, really should have used roller rockers with this setup, but it is what it is. So I got some, by shims, I mean flat washers. I got some ones here that are good, tight fitting. They match the diameter of the fulcrum really good, so they're not going to interfere with the rocker arm. And they're snug around the threads. Threads of the stud. So this should give us, well, that'll let us, won't have to run our nuts down all the way on our studs, and it will give us our preload. The more I put this engine together, the less of a fan of ARP I'm getting. I mean, it's good made hardware, but from what I've seen, they go to the top end. You know, all fasteners, all standard fasteners, you have min and max dimensions, min and max tolerances for your threads, for your diameter, for your thread pitch and your thread diameter. It seems like ARP goes to the max, which when you start stacking tolerances where the tolerances of two parts, when they put together, because you could have part A, which is made to the plus side, part B, which is made to the minus side of their respective tolerances, but once you put them together, that combined tolerance now makes the assembly out of tolerance. That's stacking tolerances. So these are close, because these lock nuts, some of them, their free running torque is higher than desired. And then likelihood to gall is also just okay. All right, we hit, not quite. We hit zero lash on that one, so we'll get some side by side, but we're not at preload yet, but we're at zero lash up and down. And we got space between the bottom of the rocker and the stud. That was another thing I was worried about, that these rockers would bottom out on the studs before we got to zero lash. Yeah, I still rock back and forth on that fulcrum, but once we get to a preload, it'll... Yep, I blew right past zero lash on that one because this exhaust valve is up on its lobe, so it started compressing the lifter. But yeah, that spray lube, that dry film lube helped a lot. Able to run these nuts down. We're still getting some heat in them, but they're not galling and seizing like they did when I checked for push rod length. Alright, that's zero lash. And now $90 degrees. And if you'll look, we just had some loosen up, some get tight. We had ones that were at zero lash that are now. But what we do, go back through, basically if a valve was open before and it's closed now, it's going to have to get readjusted. But make sure your push rods are still seated in the rockers. And we're coming up on 0 degrees. We're about 30 before top dead center, so a couple of my turns may have been a little short. So that's 2 times around. And if you look, all of the thread protrusion is more or less even between the inlets. Inlets are fairly even and the exhausts are fairly even. But I have to leave it there because I have to go make dinner. So pick this up later. That's the nice thing about this process is you can leave and come back to it. So we got a couple valves here that need a little bit more adjustment. So leave it here and come back. All right, we're back. That one. All right, do I have a 8? All right. Got one more turn. Had a phone call, so actually, before I turn it, we're getting close. Yeah, that's getting stiffer, so we got the valve train in play. Okay, so that's 2 full turns. Want to go through. Go through again. Yeah, right there, that would have been a false, because that's actually compressing the lifter. Oh, I think that's good. So, like I said before, for preload, 30 to 60 thousandths preload on a stock lifter. So one turn of these with this thread pitch will give 42. So we'll do one full turn. Half, 3/4, 1. Half, 1. Half, 1. Half, 1. Half, 1. I'm getting positive lifter compression. Half, 1. Half, 1. Half, 1. Half, 1. 1. Half, 1. Half, 1. Half, 1. Half, 1. Half, 1. Half, 1. All right, I'm just gonna run it through. Have That's weird. I'm gonna back all the intakes off 1/4. All right. I'm going to just back everything off a quarter turn. All right, now I think we're actually ready for valve covers. I already cleaned the surfaces off, so these are the Felpro rubber valve cover gaskets. They do say cover side on them, so they do have proper orientation. So let's look in the book, see what kind of torque we need. Valve cover bolts, 72 to 108 inch-pounds. I'll go to 72. Let's average that. $72 plus 108 divided by 2, 90 inch-pounds. For the valve cover bolts, it's just the original hardware that I cleaned up, and then I've had soaking in evaporust for about a week. And for paint, I'll paint the valve covers with the engine. I'll use masking tape and barrier paper to cover the valley, and I'll just paint the whole engine at one time, like they would have done at the factory. And I'll be painting it without the intake on because I like the look of a bare aluminum intake on a painted engine. Just running them down by hand first. Changed my mind. $72. Seems too high. Down to 50. Yeah, I think 50 inch-pounds is sufficient. Last thing I want to do is distort your thin metal covers, like your valve covers or oil pan, because that'll cause, because over tightened hardware will cause a leak just as quick as too loose of hardware by deforming your sealing surfaces. Still got some rust converter residue on them, but we're gonna have to clean this engine up good anyway before we paint. And that'll be scrubbing down with mineral spirits and then hitting it with isopropyl. There. I believe we'll have a long block, technically. All right, guys, that's another video. Moving right along with the engine. We're actually more or less done with the engine. Where it's assembled, valve trains adjusted. Yeah, we're aside from painting the engine and getting the intake manifold on, we're done with this thing. So with that, yeah, I'll paint the engine off camera. No one needs to watch someone play with rattle cans. So next step, I think we're actually going to be going back out to the truck, doing some work on the frame, pulling off the suspension hangers, the spring hangers off the rear of the frame, and then maybe doing some prep work to paint the frame after that. So stay tuned for that, and hope you all enjoy. And see you in the next one.